go look at number 9 real quick because I've got a key for this and I think the key is incorrect. So we talked about this question once in class already. So, maybe this is exactly the one we did in class. An object at the end of a horizontal spring is attached to a horizontal spring and it sits 4 centimeters beyond its rest position and it's released at time 0. Its position function is given by this function right here, s of t, which I've graphed in blue. So let's go ahead and label that. This is the function, well, it's labeled right here, s of t. It's been labeled s of t, great. So its velocity function then would be the derivative of this. So its velocity function would be v of t, which is s prime of t, which would be minus 4 sine of t. And I think when I went and sketched this on the key, I did it incorrectly. So let me fix that. So there's the graph of the velocity function. We'll label that v of t. Okay. So label it. We did so. Okay, so now let's go ahead and sketch the acceleration function, which is the derivative of the velocity function, which is the second derivative of our original function, acceleration. Okay. So this acceleration function would be minus 4 cosine of t, and we can go ahead and sketch that. That function starts out with a y value of minus 4. And there's the graph of it. Oops, didn't quite make it there. Okay, and so there's the graph of our acceleration function. Okay, so we've sketched it and labeled it. Okay, so at this point you can go ahead and answer a whole bunch of questions here. So I'm asking you not to use the graphs, but to actually get the information from the functions. I've had students try to read the information from the graphs, and you can do that for some of the information, but some of the information you may not be able to get straight from the graph. So what is the object's initial velocity? To find that, you would find v of 0, right? Well, that would be minus 4 times the sine of 0. But the sine of 0 is 0, so the initial velocity is 0. This object starts from rest, and let's see here, let's label this as, do we say what this is measured in? Centimeters per second. Okay. What is the object's initial position? Well, that's s of 0, which is 4 times the cosine of 0, which is 4. So its initial position is 4 centimeters. What's the object's initial acceleration? Well, that's a of 0 is equal to minus 4 times the cosine of 0, which is equal to minus 4 what, folks? What are my units there? Centimeters per second squared. And why is that squared, folks? Because I've taken two derivatives, and each time you can think of a derivative as dividing by a difference in time values. So the first derivative divides by seconds, so the second derivative divides by seconds squared. Okay, we'll just do D, E, and F together. So this says at time 5 pi over 2, the mass of, where is the mass in relation to the resting position? So you're going to find S of 5 pi over 2. And if you were to compute S of 5 pi over 2, well, that's just the 4 times the cosine of 5 pi over 2. But the cosine of 5 pi over 2 is 0, so we get 4 times 0. And we get 0, so we're at 0 centimeters from the start position. So where are we? We are at the rest position. Okay. Now, folks, you can check that on the graph. Let's do that. Let's go out to 5 pi over 2 on the graph. That's a little bit more than, let's see, there's pi over 2, pi, 3 pi, 4 pi over 2. There's 5 pi over 2 right there. And sure enough, you can see at that point in time, my position is 0. This question asks, at time 5 pi over 2, which direction is the object moving in? That is, another way of saying that is, what's the sign of the velocity? So you're going to go ahead and compute the velocity at 5 pi over 2, which is equal to minus 4 times the sine of 5 pi over 2. So the sine of 5 pi over 2 is 1, but we're going to multiply that by negative 4, so we get negative 4 centimeters per second. But the key thing here is that since the velocity is negative, we're moving to the left. Okay, folks, awfully important here. Did I make you answer that question here? No, I don't. Awfully important here for letter F. The choices are at 5 pi over 2, the velocity is increasing, the velocity is decreasing, or the velocity is unchanging. And I often have people, for this problem, they plug 5 pi over 2 into the velocity function. Because all the questions say they have the word velocity in them, right? Everyone see each answer choice has the word velocity in it? But where should I plug 5 pi over 2, folks?
Acceleration.
I should plug it into acceleration. How come? Because I'm not asking you what is the velocity. I'm asking you how the velocity is changing. Whenever I'm talking about how a variable is changing with respect to its independent variable, that's a derivative, if you can compute it. Okay. So this is actually saying, what is v prime of 5 pi over 2, which is the same thing as saying, what's the acceleration at 5 pi over 2? And if you compute that, I'll let you do so, you'll get 0. And so the answer is the velocity is momentarily unchanging. Okay, folks, I'd like to stop there.